Welcome to the Science Stories for Deep Sleep channel. In our video titled, What Would Happen on Our Planet If the World Stopped for 10 Seconds? You will learn interesting facts. Don't forget to subscribe and like before starting the video. Enjoy watching. If the Earth stopped spinning for just 10 seconds, it would be absolutely catastrophic, and I mean that in the most literal sense possible. Let me walk you through what would actually happen, because the physics of the scenario are genuinely terrifying and far more complex than most people realize. First, let's talk about how fast the Earth is actually spinning. At the equator, the surface of our planet is moving at about 1,670 kilometers per hour. That's over 1,000 miles per hour. Now, you might not feel it because everything around you is moving at the same speed, but the moment the Earth suddenly stopped, you would definitely feel it. And by feel it, I mean you'd experience something similar to being a car that slams into a wall at highway speed, except way, way worse. To put this in perspective, imagine you're driving at 100 kilometers per hour and you hit a wall. The deceleration would be brutal, potentially fatal. Now multiply that speed by more than 16 times, and you start to get an idea of what we're talking about. But it's actually even worse than that, because the deceleration wouldn't be gradual like in a car crash where the vehicle crumples and absorbs some energy over a fraction of a second. This would be instantaneous. Zero time to decelerate. The forces involved would be absolutely unimaginable. The first thing that would happen is that everything not firmly attached to the ground would continue moving at that original speed due to inertia. This includes you, me, buildings, cars, trees, oceans, and the atmosphere itself. Imagine being flung eastward at 1,670 kilometers per hour. That's faster than the speed of sound. People, animals, and objects would become projectiles, flying through the air and smashing into whatever happened to be in their path. The devastation would be instant and total. Let's think about what this would look like from different locations on Earth. If you're standing at the equator, you'd be launched eastward at maximum speed. If you're at the poles, interestingly, you'd experience almost no effect from the rotation stopping, because the poles are the axis of rotation and barely move anyway. But if you're at mid-latitudes, like most of the world's population, you'd be thrown eastward at speeds between these extremes. Someone in New York would be flung at about 1,300 kilometers per hour. Someone in London at about 1,000 kilometers per hour. Still absolutely catastrophic, just slightly less so than at the equator. Buildings and structures would fare no better. Even though they're attached to the ground, they're not designed to withstand the sudden deceleration of the Earth beneath them while their upper portions want to keep moving. Skyscrapers would snap and topple. Houses would be ripped from their foundations. Everything would crumble or be torn apart by the incredible forces involved. Think about the engineering that goes into earthquake-resistant buildings. Engineers design structures to sway and flex during earthquakes, which typically involve ground accelerations of maybe 1 or 2 GS. What we're talking about here would involve forces orders of magnitude greater. No structure on Earth could withstand it. Even mountains wouldn't be safe. The rock and soil that makes up these massive formations has some flexibility, but the sudden stop would create sheer forces that could cause massive landslides and even break apart solid rock. The Himalayas, the Rockies, the Andes, all of these geological features will be fundamentally reshaped by the event. Now, let's talk about the oceans. The world's oceans contain an unimaginable amount of water, about 1.4 billion cubic kilometers of it. And all of that water would keep moving eastward when the Earth stopped. We're talking about massive tsunamis that would make any recorded tsunami look like a gentle wave at the beach. These walls of water would be kilometers high, sweeping across continents and drowning everything in their path. Coastal areas would be hit first and hardest, but the water would travel inland for hundreds or even thousands of kilometers, depending on the terrain. The 2004 Indian Ocean tsunami, one of the deadliest natural disasters in recorded history, was caused by waves that were only about 30 meters high in some places. What we're talking about here would be waves that are hundreds of times higher, moving at incredible speeds. The entire geography of Earth's continents would be redrawn. Low-lying areas would be completely submerged. Islands would disappear. The amount of water displacement would be so enormous that it would take days or even weeks for the oceans to settle back into some kind of equilibrium. And when they did, They wouldn't return to their original basins. The distribution of water across the planet would be completely different. The atmosphere wouldn't stop either. Earth's atmosphere has mass, about 5 quadrillion tons of it, and all of that air would keep moving when the surface stopped. Winds moving at supersonic speeds would scour the surface of the planet. We're talking about winds powerful enough to strip the soil from the ground, tear apart anything still standing, and create a global sandblasting effect that would obliterate whatever the initial impact didn't destroy. The friction from these winds would generate an enormous amount of heat, potentially igniting fires across the globe. To understand just how powerful these winds would be, consider that a Category 5 hurricane has sustained winds of about 250 kilometers per hour, and those are already devastating enough to level entire towns. What we're talking about here would be 6 or 7 times faster than that, everywhere on Earth simultaneously. The atmospheric pressure differentials would be unlike anything in Earth's history. The sonic booms alone, from the air breaking the sound barrier, would be deafening and continuous. Speaking of heat, the sudden stop would convert an enormous amount of kinetic energy into thermal energy. The Earth's crust would experience tremendous stress, potentially triggering earthquakes along every major fault line simultaneously. We're not talking about earthquakes measuring 6 or 7 on the Richter scale. We're talking about potentially magnitude 10 or higher, which is theoretically off the scale of what we've ever measured. The energy release would be equivalent to thousands of nuclear weapons detonating simultaneously across the globe. Volcanoes might erupt. Actually, let me rephrase that. Volcanoes would definitely erupt. The pressure changes in the Earth's crust and mantle would force magma up through any available weakness, and the stress fractures created by the stop will provide plenty of new pathways. Volcanic activity would increase dramatically across the planet, adding ash and toxic gases to an atmosphere already choked with dust and debris from the surface devastation. The sheer amount of energy involved in stopping a planet that weighs 6 trillion kilograms is hard to even comprehend. To give you some context, the asteroid that killed the dinosaurs 66 million years ago released energy equivalent to about 100 trillion tons of TNT. What we're talking about here would be vastly more energetic than that. Some of that energy would be released as heat, some as seismic activity, and all of it would be devastating. Now here's something interesting to think about. The Earth's core wouldn't stop spinning just because the surface did. The outer core is liquid iron and nickel, and it's rotating independently from the mantle and crust to some degree. If the surface suddenly stopped, the core would keep moving, creating tremendous shear forces within the planet. This could potentially disrupt Earth's magnetic field, which protects us from solar radiation. The magnetic field is generated by the motion of the liquid outer core, a process called the geodynamo. Disrupting this would have serious consequences. Without that magnetic field protection, we'd be exposed to harmful radiation from the sun. Solar wind, which is a stream of charged particles constantly flowing from the sun, would hit Earth's atmosphere directly instead of being deflected by the magnetosphere. This would strip away atmospheric gases over time and bombard the surface with radiation. Though honestly, that would be the least of our problems in this scenario, given that everything would already be destroyed. The loss of the magnetic field would also affect electronics and power grids. We'd experience something like a massive electromagnetic pulse, frying electrical systems worldwide. Not that anyone would be around to use them anyway. But there's another layer of catastrophe to consider. Let's also consider what would happen to satellites and the International Space Station. They're orbiting the Earth at their own speeds, which are matched to Earth's rotation and gravitational pull. If Earth suddenly stopped spinning, the gravitational dynamics would change, and these objects might fall from orbit or be flung into different trajectories. The ISS, traveling about 28,000 kilometers per hour, would continue on its path while Earth stopped beneath it, fundamentally changing its orbital mechanics. The thousands of satellites we depend on for GPS, communications, weather monitoring, and countless other services would either fall from the sky or be lost to space. The debris field from destroyed satellites would make near-Earth space incredibly hazardous for centuries to come. This phenomenon, known as Kessler syndrome, would effectively lock humanity out of space for generations, assuming anyone survived to care about space exploration. After those 10 seconds, when the Earth started spinning again, you might think things would get better. But you'd be wrong. Starting back up would cause all the same problems in reverse. Anything that somehow survived the initial stop and managed to adjust to the new non-rotating reference frame would suddenly be subjected to acceleration in the opposite direction. It would be like experiencing the catastrophe twice. The oceans that had just started to settle would be thrown into chaos again. The atmosphere would be whipped back into supersonic motion. Any structures that had somehow remained standing would be subjected to another round of impossible forces. But let's be honest here. Nothing would survive to experience the restart. The combination of being flung at supersonic speeds, crushed by collapsing structures, drowned by mega-tsunamis, scorched by supersonic winds, and shaken apart by global earthquakes would ensure that essentially all life on Earth's surface would be wiped out within those 10 seconds. The only possible survivors might be organisms deep underground or in deep ocean trenches, places that are somewhat isolated from surface conditions. Bacteria living kilometers below the surface in rock formations might survive. Deep-sea creatures living in a hadal zone, the deepest parts of the ocean, might weather the storm. But even they would face enormous challenges. The seismic activity would be felt everywhere, and the disruption to the planet's systems would create a cascade of secondary effects that would last long after the 10 seconds ended. Think about the food chain. Even if some organisms survived, the ecosystems they depend on would be completely destroyed. Photosynthetic organisms would die from lack of sunlight. The dust and ash in the atmosphere would block the sun for months or years, creating an impact winter scenario. Temperatures would plummet. Any plants that somehow survived the initial catastrophe would freeze or starve for light. Without plants, herbivores would die. Without herbivores, carnivores would die. The entire web of life would collapse. In the aftermath, if we imagine somehow observing from space, Earth would look completely different. The redistribution of the oceans alone would reshape coastlines dramatically. The atmosphere would take time to settle. Fires would rage across the surface wherever there was still oxygen and fuel to burn. The amount of dust and debris thrown into the atmosphere would block out the sun, creating a scenario similar to a nuclear winter. Temperatures would plummet, and whatever ecosystems managed to survive the initial catastrophe would face an entirely new hostile environment. The planet would essentially need to start over. It would take millions of years for life to recover, if it recovered at all. Earth might end up more like Mars, a dead world with thin atmosphere, no magnetic field, and no life. Or it might eventually stabilize, and new life would evolve in the changed conditions. But the Earth we know, with its rich biodiversity and complex ecosystems, would be gone forever. It's worth noting that the scenario is, thankfully, purely hypothetical. There's no known force in the universe that could actually stop Earth's rotation so suddenly. Even massive asteroid impacts, the kind that killed the dinosaurs, don't significantly affect Earth's rotation. That impact 66 million years ago was equivalent to about 100 trillion tons of TNT, and only changed the length of Earth's day by a fraction of a millisecond. The energy required to stop our planet's spin completely is so enormous that it's beyond the realm of any realistic threat we know about. You'd need something like a planet-sized object to collide with Earth in just the right way to cancel out its angular momentum. But such a collision would completely destroy the planet anyway, melting it into a ball of molten rock, or even breaking it apart entirely. There's simply no scenario where Earth stops spinning and remains an intact planet. But thinking through the scenario really helps us appreciate the incredible forces at work in our everyday lives that we take completely for granted. We're all passengers on a massive rock spinning through space at incredible speeds. And we only stay comfortable and safe because everything else around us is moving at the same speed. The Earth's rotation creates the day-night cycle that life has adapted to over billions of years. It generates our magnetic field through the motion of the core. It influences our weather patterns and ocean currents through the Coriolis effect. The Coriolis effect is actually really important and often misunderstood. It's the reason hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It's why ocean currents flow the way they do. It's a major factor in global climate patterns. Without Earth's rotation, we wouldn't have this effect, and our weather would be completely different even if everything else remained same. The physics involved also teaches us something important about frame of reference. Right now, Sitting where you are, you feel stationary, but you're actually moving at incredible speeds. You're spinning with the Earth's rotation. You're orbiting the sun at about 107,000 kilometers per hour. The solar system is moving through the galaxy at about 720,000 kilometers per hour. And the galaxy itself is moving through the universe at about 2 million kilometers per hour. All of these motions are happening simultaneously, and we don't feel any of them because we're moving along with our local frame of reference. This is one of the key insights of Einstein's theory of relativity. There's no such thing as absolute motion or absolute rest. Everything is relative to something else. When you're sitting in a chair, you're at rest relative to the Earth, but you're moving at tremendous speeds relative to the sun, the galaxy, and the universe as a whole. It's all a matter of perspective. This thought experiment also demonstrates the concept of inertia beautifully, if horrifically. Newton's first law states that an object in motion stays in motion unless acted upon by an external force. When the Earth stops in our scenario, there's suddenly a massive external force acting on the planet, but not on everything on its surface. That's why everything would keep moving. It's the same reason you lurch forward when a car stops suddenly, except magnified to an apocalyptic scale. Inertia is also why it's actually impossible for Earth to stop instantaneously. In reality, any force strong enough to slow Earth's rotation would have to act over some period of time, and that time would matter enormously. If Earth's rotation slowed gradually over millions of years, life could adapt. We'd have longer days, different weather patterns, but it would be survivable. The catastrophe only happens because we're imagining an instantaneous stop, which violates the laws of physics as we understand them. Another interesting aspect to consider is what would happen to time itself, or at least our perception and measurement of it. Our entire concept of time is based on Earth's rotation and orbit. A day is one rotation of Earth. A year is one orbit around the sun. If rotation stopped, we'd need to completely redefine what we mean by a day. A solar day would become equal to 1 year, as it would take a full orbit for the sun to return to the same position in the sky. Though again, no one would be around to worry about keeping time. So yeah, if the Earth stopped spinning for 10 seconds, it would basically be the end of life as we know it. The good news is that this will never happen. The bad news is that thinking about it really makes you realize just how powerful the forces of nature are and how fragile our existence is when you really break down the physics of it all. We live in a delicate balance, on a planet that's hurtling through space in multiple directions at mind-boggling speeds, and it all works perfectly because of the laws of physics that govern everything in the universe. It's humbling, really. We build our cities. We create our technologies. We think we're masters of our environment. But in reality, we're entirely dependent on these massive cosmic forces that we have absolutely no control over. The Earth's rotation, its orbit around the sun's position in the galaxy, these are all things that just happen to be perfect for life as we know it. Change any of them significantly, and life becomes impossible. This is why scientists are so concerned about things like climate change and asteroid impacts, even though they're nowhere near as catastrophic as what we've been discussing. Even small changes to Earth's systems can have enormous consequences for life. We exist in a narrow range of conditions, and stepping outside that range, even slightly, can be disastrous. Pretty amazing when you think about it. We're living on a spinning ball of rock covered with a thin film of water and gas, fly to the vacuum of space at incredible speeds, and somehow it all works perfectly to support this incredible diversity of life. It's a reminder to appreciate what we have, because as this thought experiment shows, it could all be gone in an instant if the laws of physics decided to play differently. Thankfully, they don't.